We are continuing with Unit 9, Exponents and Exponential Functions, and now we're going to look at negative exponents. We're going to start with a refresher about things that we're going to need to know. So first of all, in part 1, we just have different forms of -2, either squared or cubed. So whether or not we have parentheses around that -2 really matters. In the first example, the negative just stays out front, and all that we're squaring is the 2. So since the only thing that's squared is 2, 2 is the only thing that I write twice. 2 times 2 is 4, and the negative comes down. In the second one, I'm squaring -2, so it's -2 times -2, which is a positive 4. And then you'll notice with the cubes, it actually doesn't matter if you have the parentheses or not. It's still going to just be -8. Next, we have a quick refresher about evaluating. Evaluating is any time I'm given an expression, and I also know what x and y equals. So what I've done here is I've taken my expression, and everywhere that it says x, I've plugged 6 in parentheses with its exponent. Same thing with 4 for y. And it didn't tell me z, but that doesn't matter because z to the 0 is just 1. So once I plug all that in, I can put the numerator in my calculator, put the denominator in my calculator, and then I can divide them out to get 864. Next, let's review our properties from the last concept. So go ahead and give me an example of each type of property on here. If you need to look back at your notes, that's okay. So here's a few examples I came up with. Yours might be different. But we just need to remember whenever we have the product property, when we're multiplying two like bases, we're going to add our exponents. When we have quotient, so dividing two like bases, we're going to subtract our exponents. When we have a power to a power, we're going to multiply. And anything to the 0 is 1. Our goal by the end of this lesson is for you to be able to simplify something as complex as this. Okay, so let's start looking at our property for negative exponents. So anytime we have x to a negative power, we're going to just use the reciprocal or flip it. So we can think about that as moving x to the a to the bottom of our fraction now. And then the a becomes positive once we do that. It's important to note that we only apply this reciprocal to the term that has the negative exponent. Okay, for these examples, I'm going to go over examples 1, 3, 5, and 7 with you, and then have you work out the even numbers. So first of all, example 1, x to the -5th, we are going to apply the reciprocal and move it to the bottom of the denominator since we have a negative exponent. And when we do that, our exponent becomes positive. So we get 1 over x to the 5th. Same thing with 3. Once I do this, however, I have 2 to the 3rd left, which I don't want to leave it looking like that. I can evaluate that. 2 times 2 times 2 is 8. For problem 5, the first thing I want you to think about doing is putting the exponent of -1 on one on the -2. So it is going to stay at the top of the fraction. Don't move -2 down. Same thing with y to the 5th. That's a positive 5 attached to the y, so it also is going to stay in the numerator. The only thing that we're doing the reciprocal of, the only thing we're moving across the fraction bar is x squared. Once we do that, that exponent becomes positive. Same thing with problem 7. I have a 4, so I'm going to put a exponent of 1 on there. I'm going to move the x and the y to the denominator, but I'm going to leave the 4 and the z in the numerator because they all have positive exponents. So now I'd like you to pause your video and try the even number examples and then restart your video for the answers. Here are the answers to the even number problems. If you've got questions about any of them, please ask your teacher. For this next set of examples, I'm going to work out the circled problems and then have you do the other ones on your own. So first of all, in example 9, we have x to the 5th times x to the -8. I'm going to add those exponents together. When I do, I get x to the -3. And then I need to move that to the denominator. I need to get the reciprocal of that so that my exponent becomes positive. So I end up with 1 over x to the +3. Next, for problem 10, x to the 4th over x to the 8th, I'm going to subtract my exponents since I have the quotient rule, and again find the reciprocal in order to have a positive exponent. For problem 13, We're going to start by looking at the 15 and the 21. We need to simplify that fraction. You can either use your calculator or you can think what number divides into both 15 and 21. I know that 3 divides into both those. If I divide 3 out of both, I end up with 5 and 7. So we have 5 on top, 7 on bottom. And then I'm going to move that x to the negative 2 to the bottom so that it becomes a positive 2. And then I still have x to the third on the bottom. I can go further with this problem since I have 2 x's and add my exponents using the product rule. Problem 14, let's start with putting an exponent of 1 on the 2 and also on the z. And then since we have a power to a power here, that 3 outside, I need to multiply all of my exponents by that 3. So I get 2 to the third, x to the sixth, y to the negative 9, and z to the third. I need to deal with both the 2 to the third and the y to the negative 9 still. 2 to the third is 8, so I'm going to use that. And I don't want negative exponents left in here, so I'm going to make sure I move my y to the negative 9 to the denominator and make it a positive 9. Okay, now I'd like you to pause your video and try the other 4 problems on your own and restart the video to see the answers. If you have questions about any of these, please ask your teacher. Okay, after this lesson, you should be able to use the product property, quotient property, power to power property, and power of 0 property. Oh, and you should be able to use the negative exponent property.